Good day, sir. My name is Romel F. Clarito, BSME 2A student. Today, I will tackle my answer in Evaluation 5 214 about process of vapor. Okay, number 5. Steam at 3.1 megapascal and with 74.280 degrees Celsius. Superheat rejects 1973.36 kJ per kilogram steam heat at constant pressure. Determine A, the final temperature, and B, the change in specific entropy. So, okay, our solution for that is number 1, P equals 3.1 megapascal at T saturated equals to 235.68 degrees Celsius. Let P1 equals 3.1 MPa and T1 equals to 235.68 plus 74.28. By calculating it equals to 309.96 degrees Celsius. And from steam table, H1 equals to 396.5 kilojoules per kilogram. And S1 equals to 6,5656 kilojoules per kilogram K. And next, our solution for that is QR equals to H1 minus H2. And next move will be X2 equals to H1 minus QR. So, the value of H1 equals to 3,016.5 rather, and for QR is 1,973.6. So by calculating it, our H2 equals to 1,043.14 kilojoules per kilogram. So for P equals C, point 2 is at P equals 3.1 megapascal and H2 equals to 1,043.40 kilojoules per kilogram from steam table. So our T2 equals to 235.68 degrees Celsius in wet region. So next, letter B. From our steam table, point 2 is S2 equals to 2.7137 kilojoules per kilogram K. So delta S equals to S2 minus S1. So that's our formula for that. And by substituting it, our S2 equals to 2.7157 minus the value of S1 equals to 6.5656, and by calculating it, our delta S equals to negative 3.8519 kilojoules per kilogram K in decrease in entropy. Okay, next, number 6. 5 kg of water vapor are contained 150 kilopascal and 90% quality in a suitable enclosure. So calculate the heat which must be added in order to just produce a saturated vapor. What will the pressure be at the end of the heating process? So okay, enclosed isentropic process of V equals C. Our given value P1 equals to 0.15 megapascal, Bf equals to 0.001053 meter cube per kilogram, Bg equals to 1.159358 meter cube per kilogram, while Bf equals to 466.95 kilojoule per kilogram. And next, Bg equals to 2519.21 kilojoule per kilogram. So our formula for that, B1 equals to Bf plus X1 close open parenthesis Bg minus Bf. So by substituting it is 0.001055 for the value of Bf plus 0.9 for our X1. Next, close open parenthesis for the value of Bg equals to 1.159358 minus 0.001053 for the value of Bf. By calculating it, B1 equals to B2 equals 1.0435275 meter cube per kilogram. So another formula, U1 equals to UF plus X1 close open parenthesis Bg minus UF. So equals to 466.95 plus 0.9 close open parenthesis 2519.21 minus 4661.95. And by calculating it, our U1 equals to 2315.984 kilojoule per kilogram. So okay, let's proceed for our point 2. B2 equals to 1.0455275 meter cube per kilogram. Should be 100% quality. So B2 equals to Bg at P2. By interpolating steam table, B2 equals to 1.045575, that equivalent to Yg. At P2 equals to 168 kilopascal. So okay. Next for that is, for getting the value of P2 is P2 minus Px over Py minus Px equals to Y2 minus Ygx over Ygy minus Bgx. And we're getting the value of P2 168 kilopascal. And next, okay, next QA equals to M close open parenthesis B2 minus B1. And by substituting it, QA equals to 5 close open parenthesis 2523.09 minus 2513.984. And by calculating it, our QA will be 1045.55 kJ for B equals C. Okay, next number 7. A rigid vessel contains 5 kg of wet steam at 0.4 megapascal. After the radiation of 9,585 kilojoules, the steam has a pressure of 2.0 megapascal and a temperature of 7,000 degrees Celsius. Determine the initial interval energy and the specific volume of the steam. So our solution for that, M or mass equals to 5 kg. Rigid vessel is V equals C. And next, our given value is P2 equals 2.0 megapascal, P1 equals 0.4 megapascal, and our QA equals to 9,585 kilojoules. So A, okay, at P2 equals to 2.0 megapascal and T2 equals to 700 degrees Celsius. From our steam table, B2 equals 3,471.72. Then QA will be QA equals to M close open parenthesis B2 minus B1. B1 replace, so it will be B1 equals to negative 9,585 over 5 plus 3,471.72. And then calculating it, our B1 equals to 1,554.72 kilojoules per kilogram. that equivalent to 1,553.9 kilojoule per kilogram. Next, letter B. B1, again, P1 equals to 0.4 megapascal. BF equals to 604.58. PG equals to 2,553.08. VF equals to 0.001084. And next, BG equals to 0.46258. Okay, by interpolating, V1 minus BF over BG minus BF equals to B1 minus BF over B2 minus BF. And by substituting it, so it will be 1,554.72 minus 604.58 over 2,553.08 minus 604.58 equal to B1 minus 0.001084 over 0.46258 minus 0.001084. And by calculating it, our B1 equals to 0.226 meter cube per kilogram. Next, number 8. Water vapor at 100 kilopascal and 1,500 degrees Celsius is contained in a rigid vessel. At the temperature will the vapor start to condense when the container is cooled slowly? How much heat will have to be removed per kilogram at this cooling process? So, our solution for that, for our given value, P1 equals to 0.1 megapascal, T1 equals to 150 degrees Celsius, and from our steam table, B1 equals to 1.956727 meter cube per kilogram, and U1 equals to 2582.92 kilojoules per kilogram. And next, at P2, P1 is equivalent to P2, and so at P2, or point which vapor will start to condense, and by interpolation steam table, so T degrees Celsius 91.77, T2 99.662, BG 2.27, B2 equals to 1.936727, 1.6940, BG 2496.7, B2, and 2506.1. Those numbers, those value is came from our steam table. Next, by solving it, T2 minus 91.77 over 99.62 minus 91.77 equal to 1.936727 minus 2.217 over 1.6940 minus 2.217 equals to B2 minus 2496.7 over 2506.1 minus 2496.7. And by calculating it, our T2 equals to 95.976. That's equivalent to 96 degree Celsius. While our B2 equals to 250.757411 kilojoules per kilogram. And next, move QR equals to B2 minus B1. By substituting it, QR equals to 2501.757411. That is a value of B2, while the value of B1 is 2582.92. And by calculating it, QR equals to negative 81.18 kilojoules per kilogram. That signs convention for heat rejection. Okay, number 9. Water at 2.5 megapascal and 2000 degrees Celsius is heated at constant temperature up to a quality of 80%. Find A, the quality of the heat received by the water, B, the change in internal energy, and C, the work of a non-flow process. So our solution for that, our given value is T1 equals to 200 degrees Celsius, P1 equals to 2.5 megapascal, and from steam table, S1 equals to 2.3295 kilojoule per kilogram K, while B1 equals to 849.89 kilojoules per kilogram. At T saturated equals to 200 degrees Celsius, P saturated equals to 1.55 megapascal, and getting the value of S2 and B1. So S2 equals to SF2 plus X2 close open parenthesis SG2 minus SF2, while our V2 equals to BF2 plus X2 close open parenthesis BG2 minus BF2. So okay, so by calculating it, our S2 equals to 5.6104 kilojoule per kilogram K, while our V2 equals to 2245.54 kilojoule per kilogram. So next, A. Q equals to T delta S equal close open parenthesis 200 plus 275 K, another close open parenthesis 5.6104 kilojoule per kilogram K minus 2.5293 kilojoule per kilogram, and by calculating it, our Q will be 1551.9605 kilojoule per kilogram. Next, letter B. Delta U equals to B2 minus B1, and by substituting it, delta U equals to 2245.849.89, and by calculating it, AU equals to 1595.65 kilojoule per kilogram. And last but not the least, letter C. W equals to Q minus delta B equals to 1551.9603, and it will be W equals to 156.5103 kilojoule per kilogram. Okay, next, number 10. 3 kilograms of steam initially at 2.5 megapascal and a temperature of 3700 have 2460 kilogram of heat removed at constant temperature until the quality is 19%. Determine A, the pressure when dry saturated steam exists, and B, the work. So okay, our solution for that, T1 equals to T2 equals to 570 degrees Celsius. So okay, from steam table, our steam table, T saturated equals to 570 degrees Celsius, P saturated equals to 21.4 megapascal, at P1 equals to 2.5 megapascal, T1 equals to 370 degrees Celsius. From our steam table, U1 equals to 2887.59 kilojoule per kilogram. So next, at P2 equals to 21.4 megapascal, T2 equals to 370 degrees Celsius. So next, B2, and getting the formula of B2 equals to B2 equals to BF plus X2 close open parenthesis BG minus BF. And by substituting and calculating it, B2 equals to 2,191.6 kilojoule per kilogram. Then QR equals to W plus delta U, and getting the value of W equals to QR minus delta U, and by substituting it equals to 2,460 kilojoules minus 5 kilogram times 2,887.59 minus 2,191.6 kilojoule per kilogram. And by calculating it, we'll get the value of W is negative 49.55 kilojoule. And remember and note the negative sign is disregarded. Okay, next, number 11. 3 kg of steam has an initial enthalpy of 7,200 kJ at 0.145 megapascal. Isentropic compression gives final pressure of 0.29 megapascal. Find A, the initial and final temperatures, and B, the work of a steady and non-flow processes. So, our solution for that, for letter A, H1 equals to H high 1 over M. And by substituting it, H1 equals to 7,200 kilojoule over 5 kilogram. And by calculating it, H1 equals to 2,400 kilojoules per kilogram. So, from our steam table, P1 equals 0.0145 megapascal. At P saturated equals to 0.145 megapascal. And next, T1 equals to 110.34 degrees Celsius. And next, H1 equals to HF plus X1 close open parenthesis Hg minus Hf, and that's equivalent to X1 equals to in percent. And next, by interpolation, you will get X1 equals to 6.4739 kilojoules per kilogram K, and V1 equals to 2249.16 kilojoule per kilogram. And next, also, S1 is equivalent to S2, and it will be 6.4739 kilojoules per kilogram K. At P2, 0.29 megapascal, and in T saturated equals to T2 equal to 137.37 degrees Celsius. So next, for S2 equals to SF plus X2 close open parenthesis Sg minus Sf, and equal to X2 in percent. So again, by interpolation, you will get B2 equals to 2545.39 kilojoule per kilogram, and N2 equals to 2508.82 kilojoules per kilogram. Okay, next, for letter B, Q equals Wn plus delta B, wherein Q equals 0 and S is equivalent to C. So Wn equals to negative delta B. By substituting it, Wn equals to negative 2345.39 minus 2249.16 kilojoules per kilogram times 3 kilogram. It will be Wn equals to negative 288.5 kilojoules. And next, for Q equals to delta H plus Ws. Ws, replace it. It will be Ws equals to negative delta H. And by substituting it, Ws equals to negative 2508.82 minus 2400 times 3 kilogram, and the answer will be Ws equals to negative 326.46 kilojoules. Okay, next, number 13. Steam at 5 megapascal and 4,000 degrees Celsius expands polytropically to 1.0 megapascal. According to P1, PB 1.3 is equals to C. Determine the work for non-flow and steady flow, the heat transfer to delta H and delta. So okay, so our solution for that, steam at 5 megapascal and 400 degrees Celsius superheated, wherein B1 equals to 0.057837 degree, U1 equals to 2404.5, H1 equals to 31967, while our S1 equals to 6.6483. Next, next move is B2 raised to n is equals to P1 B1 raised to n, and for finding B2, it will be B2 equals to B1 times P1 over P2 raised to 1 over n, and by substituting, B2 equals to 0.057837 times 5 over 1 raised to 1.143, and by calculating it, our B2 equals to 0.1994688. So next, letter A, finding the value of Wn, and so Wn equals to B2 minus P1 B1 over 1 minus n, and by substituting it, Wn equals to 1 times 0.1994688 minus 5 times 0.0578370 over 1 minus 1.3, and by calculating it, our Wn equals to 0.29405 kilojoule per kilogram, and also it will be 294.05 kilojoule per kilogram. Okay, next for letter B, Ws equals to n raised to Wn, and by substituting it, Ws equals to 1.3 times 299.25, and by calculating it, Ws equals to 388.77 kilojoules per kilogram. So next, okay, in a steam at 1 megapascal, the value, our given data is Bf equals to 0.0112723, Bg equals to 0.19436, Vf equals to 761.39, Ug equals to 254.7, Hf equals to 762.43, HFG equals to 2416.4, SF equals to 2.1 rather 351, and SFG equals to 4.4470. So those number is came from our steam table. And next, finding x2, the formula for that is x2 equals to B2 minus Bf over Bg minus Bf, and by substituting it, x2 equals to 0.1494688 minus 0.00112723 over 14436 minus 0.00112723, and by calculating it, our x2 equals to 1.0264. So next, finding u2. So formula for that is vf plus x2 times bg minus vf. So again, substituting it, u2 equals to 761.39 plus 160264 times 2562.7 minus 76439. And again, by calculating it, our u2 equals to 2630.78. Okay, next, number 14. Steam at 173.460 and with a specific entropy of 6 kJ per kilogram K undergoes a polytropic process with N equals 1.18 until the pressure becomes 2 megapascal. A, what is the final temperature of steam? And B, what is the work and the quantity of heat of the process? So okay, our solution for that, steam at 173.46 degrees Celsius, that will be T saturated equals to 112.4 equals U. So and our given data equals to T 173, 173.46, 174, 0.8573, P1, 0.87276, 0.22656, B1 rather, 0.2215, 2577.4, and U1, and 2578.7. So for finding P1 and B1, it will be P1 minus 0.8513 over 0.87176 minus 0.8813 equals to 173.46 minus 173 over 174 minus 173. And next, B1 equals minus 0.0573 over 0.87176 minus 0.8573 equals to 173.46 minus 173 over 174 minus 173. And by calculating it, the value of P1 equals to 0.864 megapascal, while our B1 is equal to 0.224. Okay, next, finding B2. The formula for that is B2 equals to B1 times P1 over P2 raised to 1 over N. And by substituting it, B2 equals to 0.224 times 0.561 over 2 raised to 1 over 13. And by calculating it, B2 equals to 0.1097. Next, for Wn, is equal to P2 B2 minus P1 B1 over 1 minus N. That is the formula for Vn. And by substituting it, Wn equals to 2 times 0.1097 minus 0.861 times 0.224 over 1 minus 1.18. And by calculating it, our Wn is equal to negative 0.147.42 kilojoule per kilogram. So next, by getting the value of U1, so U1 minus 2577.9 over 2578.7 minus 2577.9 is equal to 173.46 minus 173 over 174 minus 173. By calculating it, our U1 equals to 2578.268. So next, for finding U2, okay? So for finding U2 is V2 minus 2597.3 over 2597.5 minus 2597.3 equals to 0.1097 minus 0.11061 over 0.10846 minus 0.11061, and by calculating it, our U2 equals to 2597.385. Next, for our delta U, the formula for that is delta U equals to V2 minus V1, and by substituting it is 1597.385 minus 2578.268, and by calculating it, delta U equals to 19.117. And next, for our Q, and the formula for that is Q equals to delta U plus Wn, and by substituting it, Q equals 19.117 plus negative 107.42, and by calculating it, our Q equals negative 128.308 kilojoules per kilogram. So that's it.